Next is progressive wave equation. Progressive wave equation. Progressive wave equation. Right? Now, you know what is this progressive wave? Progressive wave is one form of the transfer wave such that amplitude is same. This amplitude is same. So this amplitude is same. It is known as progressive wave. So it is progressing. Wave will progress like this, such that this amplitude is same. What is amplitude? From the mean position to this maximum position, the distance which you are taking here on y-axis. This is time axis. So this distance is known as amplitude. So this is a progressive wave. So for this one we have to write a equation here. Right? Now see here, y equal to this y, because y is a function, no, we have to write down the function, or we have to write the which one progressive wave in terms of the mathematical function here, right? So here what I will write is, here just I will write this as a sine phi first. Why? Because y is proportional to a. You can see here this y displacement, because a means you are taking on y-axis, no, this displacement values, a value you are taking on y-axis here. So y is proportional to a. So you are getting the value of y, the value of a on this y-axis. So y is proportional to a, right? Okay. And this one, sine function. What is phi? Phi is phase difference. Already we discussed what is phase difference in previous video. So this is phase difference, right? So why we are writing that phase difference is, you can see this one, this form, whatever the wave you are which one getting here, the wave form which you are getting, this I am taking a sine form, because this amplitude is same here, right? A curve between -1 +1 you can write in a sine function, right? Or in a cos, in some textbooks they are writing in cos function, but you can take sine also. So your y displacement is proportional to a, and it is a sine function with phase angle. Why I am writing phi here? Because this one also already discussed here. This is 0, this 90, this 180, this 270 and 360 degrees, right? So when the wave is traveling here, so this is a phase of pi by 2, out of phase of pi by 2. If this is not there, you can say your which one curve is out of phase of pi by 2, pi by 2 minus 0. So these are the phase angles here, pi by 2, 180, 270 and 360, right? So your function, whatever the y function depends on which are two variables here. One is a, second is angle phi, and one more is sine, right? Now with this figure we got that y equal to a sine phi, because your y depends on these three, a, sine and phi. You can take cos also, no problem. So right, so y equal to a sine phi. So your y displacement depends on these three, a, sine and phi. So this is the curve form which you are getting, this sine form, right? So this displacement, and these are the phase angles. Okay. So total form writing in a mathematical form, y equal to a sine phi. Okay. Right. Now what is phi? Y equal to a sine. Phase angle formula already which one in the previous this one we have discussed. This is 2 pi by t into t. So this already formula I had showed in the previous video, how to get the which one phase difference. So this phase difference is 2 pi by t into t, right? So 2 pi, not this is t, 2 pi by t into this is small t, right? T is the time period. What is time period? This one also you can see my previous videos. This is the total length of the wave. So this one you can take as time period t. Completion of one cycle means one thrust and one trough. starting ending point mean position. This is known as one wave. One wave is completing how much time? That is time period t, and this can be taken as lambda also. That is wavelength is this one, time period is this one, right? So 2 pi means this angle is 2 pi. So correspondingly, your time period is 2 pi. So with that I got this equation 2 pi by t into t, right? So already that one we discussed here. So if you take a this time difference, if you take another wave, a time difference will be there, that is delta t. So for t you are getting 2 pi, no? For time period t, this is angle 2 pi. So I want for delta t. So delta t, what is phase angle? So your phi will be this one, 2 pi, 2 pi, 2 pi by t into delta t. So this formula only I wrote here, 2 pi by t into t. Okay. 2 pi by t, this capital T. Right? Now your equation, this one is equation. So y equal to a sine this one 2 pi 1 by t is frequency into t, right? So this y equal to a sine, this is angular frequency w. So your standard equation is y equal to a sine omega t. So you can take the equation as y equal to a sine omega t. So when a wave is propagating like this, or when wave is progressing like this, right? So this yt, so this is a time axis. Now you can take this mathematical equation as y equal to, because a progressive wave, because displacement is same. When displacement is same, it is a progressive wave, right? So this one, so total mathematical form can be taken as a sine omega t. So in the textbook they are writing directly, considering the equation of this progressive wave y equal to a sine omega t. Why I got this omega t already explained, right? So this is a y equal to a sine omega t. At point O I am taking this one. Y at O is a sine, right? Starting point, your wave is a sine omega t, right? Suppose I will take a point P here, right? You take any point, P already points are in this. You can take this point as suppose E point. So y at E. So what is y at E? So this is a sine omega t minus phi, because here already suppose this is 90 degrees, this is 180 degrees. So to get the which one phase difference here, what you are doing, 180 minus 90 you are doing, right? So here this one is actually phi only, because with phi only I got this W2, already explained. No, with phi only I got this W2. So this W2 is phi. So at this point this is phi. At this point, what is that value? This again, omega t is this phase. Suppose you are taking this point, no? This point phase is omega t, again this is phi. So for this omega t phase belongs to point E, because this is point E. So to get the phase difference, what we have to do? We have to subtract the angle of E with respect to O. So what is the phase angle here? Omega t. Your phase is phi here, this phi. So omega t minus phi, right? So in the textbook they are writing directly, why not y at this one is a sine omega t, y at E is a sine omega t minus phi. But the how we are writing, so that we have to know, right? So again I am explaining here, this omega t is phi here, so we have to subtract the phase, to get the phase difference you have to subtract this angle. So here phase is omega t again, so here phase is phi, so omega t minus phi, because this I took already phi now. This omega t corresponds to point E phase, this one corresponds to this point O phase. So y at E equation is a sine omega t minus phi. Okay, I think up to here it is clear for you, right? Now I will take this equation, y equal to y at E, I got equation as a sine omega t minus phi. Okay, right? So for this one, you can write down equation as this omega is 2 pi by t, okay. This phi is 2 pi by lambda into x. This is again phase, which one phase difference, having two formulas. We have 2 pi by lambda into delta x, this one formula. Other formula is 2 pi by t into delta t. So this is the path difference, this is a time difference. So in the previous videos already explained this one, how we got. So wave is like this, the full length of the wave. This full length of the wave is known as lambda wavelength, and this is also known as time t, time period t. So both values equal to 2 pi, right? So both values equal to 2 pi means your lambda value is equal to 2 pi corresponding value, and your t value is corresponding value is 2 pi. So for lambda means this is in meters, no? This is a path difference, how much phase angle. This time means how much time difference, delta t. What is the phase angle? So with this one, what is phi? You are getting 2 pi by lambda, this one, 2 pi by lambda into delta x. From this equation, from this relation you are getting this one. From this relation you are getting this one, 2 pi by t into delta t. So this phase difference is with respect to path difference. This phase difference with respect to time difference, right? So here I am writing this omega as 2 pi by t, this one, 2 pi by t, this omega naturally. This one angular frequency. This one phi is this one, 2 pi by lambda into this formula I am writing. This is phase difference with respect to path difference. This is with respect to time difference. So we got two here, time difference and path difference, right? Now you can take this 2 pi common, 2 pi common, 2 pi into t by t minus x by lambda. So this one form of the equation, y of equal to a sin 2 pi t by t minus x by lambda, right? And this can also be written as sin 2 pi, right? So what is 1 by t? Already we know that velocity equal to velocity of the wave is distance. What is distance? Wavelength here. What is time? Time period. So what is 1 by t value? V by lambda. So this 1 by t you can write down v by lambda here. This is another form, right? So this equation becomes a sin 2 pi by lambda is LCM here, Vt minus x. This is another form, right? Y equal to a sin 2 pi by lambda into Vt minus x, right? Now, so all these equations are when a wave is moving in this direction. When a wave is moving in opposite direction, then the equations will be, we have to change the sign, right? Okay. So when the wave is moving like this, suppose wave is moving like this, right? So your wave is moving like this, in this way, in this way. So here what is the equation we got? Y equal to a sin omega t minus kx, right? So this is the equation we got. So why I got k value? Because that equation is there, no? A sin, we have written that equation, no? This one, omega is 2 pi by t into t. This one is 2 pi by lambda into x. We have written this equation, no? So this 2 pi by t is omega, right? The 2 pi by lambda is known as wave number, that is k. So this is wave number. It is the ratio of phase difference to the path difference. 2 pi is the phase difference and lambda is the path difference. So that ratio is defined as wave number. So your form is y equal to a sin omega t minus kx. So what is the form here when wave is moving in this direction? Y equal to a sin omega t plus kx, right? Right. So y equal to a sin omega t plus kx. So this minus becomes plus here because it is moving in this direction, right? Okay. Next one is the equation which I have done, y equal to a sin 2 pi by, the equation we have written 2 pi by lambda into, this is Vt minus kx. So this equation we have written Vt minus kx. So here this will be plus here, y equal to a sin 2 pi by lambda into Vt plus kx. Okay, so this is the equation, right? So these are the which are standard equations for a progressive wave. So whenever you want to write a equation for a progressive wave, so this is a progressive wave, right? So this y of t, this is time t. So what is standard form now? We can write down y equal to a sin omega t minus kx. So this is a standard equation we have to remember. It's important, right? So this is amplitude, right? Sine form, and this one is already explained how we got omega t and kx. K is known wave number, omega is that is 2 pi by t. So everything in the form, this is the standard form, y equal to a sin omega t minus kx is the equation for a progressive wave. Okay, and the wave moves in this direction. When wave is moving in this direction, this will be plus y equal to a sin omega t plus kx. Okay, right? Okay, thank you.